In this video, I am going to discuss about the various laws of logarithms. Now, let us see the first law of logarithm. It says logarithm of product of two numbers is equal to sum of the logarithms of the numbers taken to the same base. That is, log mn to the base a is equal to log m to the base a plus log n to the base a. Now, let us see the proof of this law. Proof. Let us take log m to the base a as and log n to the base a as y. So, this means log m to the base a equal to x means a raised to x is equal to m, and log n to the base a is equal to y means a raised to y is equal to, now we have mn is equal to a raised to x into a raised to y. You know from the law of indices, if we have a raised to m into a raised to n, then that is equal to a raised to m plus n. So, here we have a raised to x into a raised to y is equal to a raised to x plus y. So, by the definition of logarithm, we have, so this implies mn is equal to a raised to x plus y. By the definition of logarithm, we have log mn to the base a is equal to plus y, x is log m to the base a and y is log n to the, this by definition of. So, we have the log of the product of two numbers is equal to sum of the logarithms of the numbers taken to be. Let us take an example. Now, let us take log of 15 to the base 10. We can write log 15 as log 3 into 5 the base 10. This is equal to log 3 to the base 10 plus log 5 to the. So, this is how we can express the product of two numbers. It is the logarithm of product of two numbers as the sum of logarithms of the numbers. The next law is the logarithm of quotient of two numbers is equal to the difference of the logarithms of numbers taken to the. This log m divided by n to the base a is equal to log m to the base a minus log n to the base. Let us see the proof of this law. Again, let us take log m to the base a as x and log n to the base a as y. So, this implies a raised to x is equal to m and a raised to y is equal to. Now, considering m divided by n is equal to a raised to x by to y. From the law of indices, we know that a raised to x by a raised to y is equal to a raised to x minus y. So, we have m by n is equal to a raised to x minus y. By definition of logarithms, we have log of m divided by n to the base a is equal to x minus y. This by definition. Here our x is log m to the base a and y is log n to the. So, this is how we have got log m by n to the base a is equal to log m to the base a minus log n to the base a. Let us take an example. Say log of 31 by 5 to the base, let us take 10. Log 31 by 5 to the base 10 is equal to log 31 to the base 10 minus log 5 to the base. So, we can write log 31 by 5 to the base 10 as log 31 to the base 10 minus log 5 to the base 10. This is an example. The next law says the logarithm of a number raised to an index is equal to the product of the index and logarithm of the number taken to the, that is log m raised to n to the base a is equal to n into log m to the base a. Now, let us see the proof of this. Again, I am taking that log m to the base a is equal to x. So, this implies a raised to x is equal to m. Now, you want the number m raised to n. M raised to n is equal to raised to x whole raised to n. So, this is equal to a raised to x into n. So, by definition of logarithm, we have log m raised to n to the base a is equal to x to n, or I am writing it as n into x. This is equal to n into x is nothing but log m. So, I have got log m raised to n to the base a is equal to n into log m to the, small example, log of 3 square to the base 10 can be written as 2 into log 3 to the. So, this is how we can write log 3 square to the base 10, it is equal to 2 into log 3 to the base. The next one is regarding change of base. If we want to change the base of the number, then we can use this relation. It is given the logarithm of a number taken to any base can be changed to logarithm of the same number taken to another base using the following relation. Here log m to the base a is equal to log m to the base b into log b to the base a. That is, we want to change our number m, it is to the base a, we want to change it to the base b. In that case, we have to perform this operation. We have log m to the base a is equal to log m to the base b into log b to the base a. From this, we can get log m to the base b is equal to log m to the base a divided by log b to the base a. Now, let us see the proof. Taking that log m to the base a is equal to x, log m to the base b is equal to y, and log b to the base a is equal to z. So, this implies a raised to x is equal to m, and from here e raised to y is equal to m and raised to z. So, here we have a raised to x is equal to m and e raised to y is also equal to m. Since the right hand sides are equal, I am equating the left hand sides. So, I am getting a raised to x is equal to b raised to y. From here, I am substituting b is equal to a raised to z. From here, I am substituting b is equal to a raised to z. So, a raised to x is equal to a raised to z the whole raised to y. Since we have b is equal to z. So, this implies a raised to x is equal to a raised to y, which means x is equal to y. Now, what is our x? Our x is log m to the base a is equal to y is log m to the base b and z is log b to the. So, we have got. I hope this is clear. So, from this we can write log m to the base b is equal to. From this we can write log m to the base b is equal to log m to the base a divided by log b to the. Now, we just now saw log m to the base a is equal to log m to the base b into log b to the base a. In this I am substituting m is equal to, that is log m to the base a is equal to log m to the base b to log b to the base a. Now, I am putting m is equal to a in this relation. What will I get? I will get log a to the base a is equal to log a to the base b to log b to the. We know that log a to the base a is equal to 1. So, 1 is equal to log a to the base b to log b to the. Since log a to the base a is to 1. So, I have got the relation log a to the base b. So, I have got the relation log a to the base b into log b to the base a is equal to 1, or in other words log a to the base b is equal to 1 divided by log b to the base. In my previous change of base relation, I have log m to the base a is equal to log m to the base b into log b to the base a. In this I am substituting m is equal to a. When I am substituting m is equal to a, I have got this relation. Now, we will do a few practice questions using these laws. First one is simplify a raised to 5, simplify log a raised to 5 minus log a raised to 4. We know that log m minus log n is equal to log m divided by. So, log a raised to 5 minus log a raised to 4 is equal to log a raised to 5 divided by 2. This to the same base. So, next we have log a raised to 5 minus a raised to 4 is equal to a raised to 5 minus 4, which is log a raised to 1 is equal to log a. Next question says simplify log 9 divided by log 3. So, have to be very careful according to one of the laws. The law says log m by n is equal to log m minus log n. But here we have log 9 divided by log 3. So, we have to be very careful. We cannot simply write this log 9 by log 3 as log 9 minus log 3. It is wrong. So, we have to be careful. Okay. So, here log 9 divided by log 3. I am simplifying log 9. You know that the value of 9 is 3 square. So, I am writing log 9 as log 3 square divided by log 3. We know that log m raised to n the base a is equal to n into log m to the a. So, here log 3 square is 2 log 3 divided by log 3. I can cancel this log 3 and this log 3. So, the answer is, so this is how I have simplified log 9 divided by log 3. The next question we have, simplify log 121 divided by log root 11. So this log 121, I am writing it as log of 11 square divided by log square root of 11, I am writing it as 11 raised to half. You know that log a raised to n is equal to n log a. So log 11 square is equal to 2 log 11 divided by log 11 raised to half is equal to half log 11. Here, since log a raised to m is equal to so this cancelling this log 11 and this log 11 is equal to 2 divided by, if I have to multiply this 1 by 2, then I have to write the reciprocal. So 2 divided by 1 by 2 is equal to 2 into 2 divided by 1 is equal to 4. So the value of log 121 by log root 11 is equal to 4. The next question, evaluate log of 10 divided by cube root of 10. So they have asked us to assume the base as 10. Even if there is no basis given, you can assume it as 10. This log of 10 divided by cube root of equal to log 10 minus log cube root of, using the second law, log m by n is equal to log m minus log n. This is equal to log 10 minus log 10 the whole raised to 1 by 3. Here we have asked to assume the base as 10. We know that log a to the base a is equal to 1. So log 10 to the base 10 is equal to 1. So this is 1 minus, here we have log 10 raised to 1 by 3. It is 1 by 3 log 10. This is equal to 1 minus 1 by 3 into log 10 is 1. So this is equal to 1 minus 1 by 3. Taking the LCM as 3, I am getting 3 minus 1 divided by 3. 3 is equal to 5. So the value of log of 10 divided by cube root of 10 to the base 10 is equal to by 3. The next question, evaluate log 2 plus log 5 minus half log 36 minus log 1 by 30. So I am simplifying this, equal to log 2 plus log 5 minus half log, this 36 I can write it as 6 square because 36 is equal to 6 into 6 minus log of 1 by 30. Here 1 by 30 I am writing it as log 30 raised to minus 1 because we know that 1 by a is equal to a raised to 1. This is equal to log 2 plus log 5 minus half into log 6 square is 2 log minus log 30 raised to minus 1 is minus 1 log 30. So this is equal to log 2 plus log 5 half into 2, this 2 gets cancelled, minus log 6, minus of minus 1 is plus 1 into log, this is equal to log 2 plus log 5 minus, I am writing log 6 as log of 2 into 3 plus I am writing log 30 as 3 into, log 30 is 3 into 10, that is 3 into 2 into 5. So, this is equal to log 2 plus log 5 minus of log a into b. This is of the form log a into b, it is log a plus log b. So, log 2 into 3 is log 2 plus log 3 plus log 3 into 2 into 5 is log 3 plus log 2 plus log 5. So, this is equal to, here I have 1 log 2, here I have 1 log 2 minus log 2, I have 1 minus log 2 here. So, I have 2 log 2 minus log 2, it is 1 log 2. Then I have log 5 here and log 5 here plus log 5 plus log 5. So, it is plus 2 log 5. Then I have minus log 3 here and plus log 3 here. So, these two will cancel out. So, equal to log 2 plus log of 5 square. So, this is equal to log 2 plus log 5. So, log a plus log b is equal to log ab. So, this is equal to log. So, we have found the answer for the given question. Log 2 plus log 5 minus half log 36 minus log 1 by 30 is equal to log. The next question is, if a is equal to 100 raised to p, b is equal to 10,000 raised to q, c is equal to 10 raised to r, express log 10 root b divided by a square c cube to the base 10 in terms of p, q and r. So, we have to find log of 1, log of 10 root b by a square c cube to the base 10. So, log of 10 root b divided by square cube the base 10 equal to, substituting the values for a, b and c. This log of n into square root of b is square root of 10,000 raised to q divided by a square. A is 100p, sorry 100 raised to p the whole square. C cube is 10 raised to r the cube. This is equal to log of n into 10,000 is 100 square whole raised to q the root divided by 100 raised to p the whole square is 100 raised to 2p into 10 raised to r the whole cube is 10 raised to 3r is. So, this is equal to log of, here we have this 10 into 100 square the whole raised to q, writing it as 100 raised to 2q, under root I am putting it as the whole raised to half, divided by, here I am writing this 100 as 10 square. So, 10 square the whole raised to 2p into 10 raised to 3r is. This is equal to log of, here 100 raised to 2q the whole raised to half is 100 raised to 2q into half. So, this 2 and this 2 will get cancelled. So, we are left with log of 10 into 100 raised to q divided by 10 raised to 4p to raised to pr is 10. So, everywhere we are having the form of 10 raised to some index except for this 100 raised to q. We will change that one also. So, this is equal to log of 10 into 100 is 10 square the whole raised to q divided by 10 raised to 4p into 10 raised to r. Yes. So, this is equal to log of this 10 raised to 1 into 10 raised to 2q divided by, here this is of the form a raised to n into a raised to m, it is equal to a raised to m plus n. So, 10 raised to 4p into 10 raised to 3r is 10 raised to 4p plus r. So, this is equal to log of, the numerator we have 10 raised to 1 into 10 raised to 2q. So, it is 10 raised to 1 plus 2q divided by 10 raised to 4p plus 3r, the base 10. So, this is of the form, this log of this number, this is of the form log of a raised to m divided by a raised to n, that is equal to log of a raised to m minus n. This is equal to log of 10 raised to 1 plus 2q minus 4p minus 3r, the base 10. Now, we know that log a raised to m is equal to m into log a. So, this is equal to 1 minus 4p plus 2q minus 3r into log 10 to the 10. We have another result, log a to the base a is equal to 1. So, from that we can say log 10 to the base 10 is equal to 1. So, the answer for the given question is 1 minus 4p plus 2q minus 3r. So, the answer. This becomes equal to, so the answer is, that is log 10 would be divided by a square c cube to the base 10 is equal to 1 minus 4p plus 2q minus 3r. So, we have expressed this in the form of terms of p, q and r. The next question, if log x to the base 2 plus log x to the base 4 plus log x to the base 16 is equal to 21 by 4, find the value of. So, here we have to use the relation change of base and we have to write all the logarithmic terms in a single base to solve this problem. So, here we have first one, I am taking log x to the base 2, writing all the logarithmic terms to the base 10. So, log x to the base 2 is equal to, have the relation log m to the base a equal to log m to the base b divided by log a to the So, here log x to the base 2 is equal to log x to the base 10 divided by log 2 to the only when we have all the terms to the same base, it will be easy for us to simplify. Next one, log x to the base 4, writing it as log x to the base 10 divided by log 4 to the next one, log x to the base 16 is log x to the base 10 divided by log 16 to the. Now, my left hand side is log x to the base 2 plus log x to the base 4 plus log x to the base. I am substituting these values. My left hand side becomes log x to the base 10 divided by log 2 to the base 10 plus log x to the base 10 divided by log 4 to the base plus log x to the base log 16 to the. Next step, simplifying, taking log x to the base 10 outside. So, I have 1 by log 2 to the base 10 plus 1 by log 4 to the base 10, I am writing it as log 2 square to the base 10 plus 1 by log 16 to the base 10, I am writing it as log 2 raised to 4 to the base. So, the next step, my left hand side is log x to the base 10, it is outside, and to simplify the term inside the bracket is log x to the base 10 to 1 by log 2 to the base 10 plus 1 by, next term was log 2 square to the base 10, log 2 square to the base 10 is 2 log 2 to the base 10 plus the next term was 1 by log 2 raised to 4 to the base 10, that is 1 by 4 log 2 to the is equal to log x to the base 10 divided by, I am taking log 2 to the base 10 outside. Here I am having 1 plus 1 by 2 plus, so this is equal to log x to the base 10 divided by log 2 to the base 10 to taking 4 as the LCM. So, here first term is 4 plus the second term is 2 plus 1. Here 4 by 4, 2 by 2 plus 1. So, the LCM is 4. Numerator I have 4 plus 2 plus 1 is equal to log x to the base 10 divided by log 2 to the base 10 into 7 by, now what is this? This is equal to 21 by 4, it is given in the question, this is equal to 21 divided by 4. So, this 4 cancel out and this one goes. So, from this I get log x to the base 10 is equal to 3 times log 2 to the base 10. 3 times log 2 to the base 10 is log 2 cube to the base 10 is equal to log 8 to the base 10. So, I have got log x to the base 10 is equal to log 8 to the base 10. So what is x? X is equal to, so we have found the value of x. So when we have to simplify any logarithmic terms which is having different base, first we have to convert all those different bases into logarithmic numbers of same base. Next question, prove that 1 by log ABC to the base A plus 1 by log ABC to the base B plus 1 by log ABC to the base C is equal to 1. Again we are having different bases. We have to the base A, to the base B and to the base C. So we have to convert all these to a single base. So first, writing it here, log ABC to the base A is equal to log ABC to the base A is log ABC to the base 10 divided by log A to the base 10. Next term in the denominator is log ABC to the base B is equal to log ABC to the base 10 divided by log B to the base. Next term is log ABC to the base B, the base C is equal to log ABC to the base 10 divided by log C to the. I am substituting all these in my left hand side. In my left hand side I have 1 divided by log ABC to the base A. So I have to write the reciprocal of this. And for 1 divided by log ABC to the base B, I have to write the reciprocal of 1 and so on. So 1 divided by log ABC to the base A is equal to log A to the base 10 divided by log ABC to the base 10 plus. Next one is 1 divided by log ABC to the base B. I am writing the reciprocal of this. This log B to the base 10 divided by log ABC to the base plus. Next term is 1 divided by log ABC to the base C. So, I am writing the reciprocal of this term. It is plus log C to the base 10 divided by log ABC to the. Here all my denominators are same. So, on taking LCM, I get this common denominator log ABC to the base 10 and I can add the, it becomes log A to the base 10 plus log B to the base 10 plus log C to the base. So, this is equal to, we know that log A plus log B is equal to log AB. So, this one is, I am using the first two terms, I get log A plus log B is equal to log AB to the base 10 plus log C to the base 10 divided by log ABC to the base 10. Again I am extending here, in place of A I have AB and in place of B I have C. So, log A plus B is log AB. So, here it is log ABC to the base 10 divided by log ABC to the. These both term cancel out and I get the answer as 1. This is equal to the. I hope this is clear. Next one is prove that log A to the base B into log B to the base C into log C to the base D is equal to log A to the base. Here again the bases are different. We have to convert this into single base. Since we have already practiced a few questions, I am writing it directly here. Log A to the base B, I can write it as log A to the base 10 divided by log b to the base 10 into log b to the base c. I can write it as log b to the base 10 divided by log c to the base 10 to log c to the base d. I can write it as log c to the base 10 divided by log c to the base d is equal to log c to the base 10 into log d to the. So, here my left hand side. This log b to the base 10 log b to the base 10 cancel, equal to 1. Here log c to the base 10 log c to the 10 get 1. So, we are left with log a to the base 10 divided by log d to the. This is nothing but log a to the d. By using the relation change of base, we have got log a to the base 10 divided by log d to the base 10 is equal to log a to the. Want I can write the formula, since log m to the base a is equal to log m to the base b log e to the a is log m to the a log. Here our a is 10, our m is a and our b is. Hope this is clear. I hope this video was useful for you. My next video I will be discussing about logarithmic tables, how to use log tables, find the value of huge quantities. Thank you for watching.